Hi guys, so as promised, I have another video for you that will walk you through another example problem of how to compute a one-way chi-square. So just as a really quick review, with the one-way chi-square, we have one categorical variable, right? And a categorical variable is a non-numeric variable. So it's going to be a variable like gender or political affiliation, where we have different levels. So for example, we have male, female, or Republican, Democrat, Independent. And we use numbers to represent those different levels in our data set, such as using 1 and 2 for male, female respectively, or 1, 2, 3 for Republican, Democrat, Independent respectively, but they don't actually have any sort of quantitative or magnitude factors associated with them, right? So essentially the question that we're asking when we conduct a one-way chi-square is very similar to the question that we ask when we conduct a one-sample t-test. And that's essentially a question of whether the statistics that we observe in our sample are different from those we would expect to find in the population. Okay? So with a one-way chi-square, we are working with a categorical variable, a single categorical variable, and we're trying to decide whether the percentages or frequencies that we see in our sample fit or mirror those we would expect to find in the population. Okay, so for this particular example, we are trying to find out whether the Skittles company is correct when they say that there is an equal number of each flavor in each bag of Skittles. Okay? So we're trying to determine whether the Skittles factory makes equal amounts of all 5 Skittles flavors, right? So what I have here represented in this picture is a given sample, okay? So these are all the Skittles found in one bag of Skittles, one of the big bags of Skittles, okay? And indicated here for you is the number of each flavor of Skittle that was observed in this particular sample or bag of Skittles, right? So we have, for example, 80 red Skittles, 74 orange, 74 yellow, 91 green, and 65 grape, okay, or purple. So if it were the case that we had an equal number of each flavor represented in our bag, right, we would expect to get approximately 76.8 of each flavor, right? So we know that's not the case. We know our observed values are different from those we expect. But are they different enough? So is 80 significantly different from 76.8? Well, we don't really know. What about 74? Or certainly about 91. That seems like it must be significantly different, right? So essentially that's what we're trying to test with a one-way chi-square is, are the observed number of Skittles for each flavor different from what we would expect should they all be equal? Okay, so remember our first step is to state our null and alternative hypotheses, right? So again, our null hypothesis is that the factory is going to make equal amounts of each flavor, right? So just thinking about that in terms of percentages, there are 5 different flavors of Skittles in a standard regular Skittles bag. So that would correspond to 100 divided by 5, which is about 20%. So we would expect 20% or 76.8 of each flavor. And by the way, where I got the 76.8 was I added up rather, all of the frequencies for each of the flavor of Skittles. So 80 plus 74 plus 74 plus 91 plus 65 is about, I believe, 384. Okay, so if I divided 384 by 5, that was equal to about 76.8 of each flavor. Okay, so again, our null hypothesis is that the factory makes equal amounts or 20% of each flavor, which again, just for our purposes, is about 76.8 Skittles of each flavor. And the alternative hypothesis is that the factory doesn't make equal amounts of each Skittles flavor. Okay. All right, so now we're going to make a table very, very similar to the table that we made for the ice cream example, right? So the first two columns, we already have that information, right? So the observed frequencies we have in our first picture there of all the Skittles. So we have 80 red Skittles, 74 orange, 74 yellow, 91 green, and 65 purple. And again, we would expect 76.8 Skittles approximately of each flavor. So that's our expected value. And then we're going to subtract the expected value from the observed value. Okay, we're going to square that difference. And then we're going to take that squared difference and divide it by the expected value. And then the final step is we're going to add up all of the numbers in that last column for each of the 5 categories. So we're going to add up 0.13, 0.10, 0.10, 2.63, 1.81, and we get an obtained critical value or an obtained chi-square value of 4.78. So now we have to look up our critical value. So now that we have our chi-square value, before we look it up in the table, we need to find out what our degrees of freedom are. So our degrees of freedom are 5 levels. So there are 5 flavors of Skittles, and we're going to subtract 1, which gives us 4. Our alpha level is always set to 0.05. So that gives us a critical value of 9.49. Okay, so now we have to decide whether we reject or retain the null hypothesis, right? So our critical value was 9.49, which is bigger than our obtained value of 4.78. So therefore we retain the null hypothesis. And if we were to write that up in formal APA style results, we would first want to indicate the type of test that we conducted. So we would say a one-way chi-square test indicated that the percentages of red, orange, yellow, green, and purple Skittles, okay, reporting the percentages in parentheses were not significantly different from the expected percentage of 20% each. Okay, so again, how I got the percentages is I took the number of Skittles of each flavor and I divided it by 384, which is the number of Skittles in the bag, and I got 20.83 for red, 19.27 for orange, 19.27 for yellow, 23.69 for green, and 16.92 for purple. Okay. And again, when we report anything in APA style, we want to make sure we have the tests we conducted. We want to make sure we have our descriptive statistics, which in this case are the observed percentages for each level of the categorical variable. Okay, and we want to report our obtained chi-square value, our degrees of freedom in parentheses, and we want to indicate whether the p-value was greater or less than 0.05. So because the critical value was bigger than the obtained chi-square value and we had to retain the null hypothesis, we would say that P is greater than 0.05. Okay, so hopefully this makes sense. Certainly if you have any questions, don't hesitate to contact me, and I look forward to seeing you in my next video.